Don't panic. It's not a mailbag. This is a parcel sent to me by Atul Ravi, and it's arrived in Australia. The rest of the stuff I've tried to burn out and created a hole. That was great. And on the other side, there's so much paperwork. Like, for instance, more paperwork than John Nash's Nobel Prize winning, what was it? Economics, I think, something to do with game theory. A one-pager, beautiful. But the custom stuff underneath here, a lot of paperwork coming in from Atul, well, from Atul's country, from India. So I'll open this up, and maybe what we'll do is we'll see what's inside and what's survived the burnings at least, and then a little package. Is there anything else in there? No, but it's quite heavy on the outside because of the paperwork. But I'll talk about Atul in a little bit, but first we'll see what he sent me. I don't know whether this is a sponsored video or not. I'm always, like, Atul sent this to me. I think it's a commercial product, or it's going to become a commercial product. There's some paperwork here. Let me have a look at that. Is it a note that's got lots of stuff on it? It is. Let me see what I can read out from this one. Hi, OneCircuit, let's say it says. I hope this package and letter reach you safely. Yes, Atul, it has. I've included one PicUNO board. Okay. One PicUNO board. So what is a PicUNO? It is an Arduino Uno form factor, which we well recognise. Let's see if I can get it where it's not going to flare. But this isn't an Atmega 328 driving this thing, and there's some other bits and pieces which you may or may not recognise either. That's an RP2040. And we'll compare the specs on that at some stage. That looks like an addressable RGB, perhaps a 2812 maybe. It's very prototypey, very much in the handmade genre, made in India, nice. Open source hardware, so that you can get to some more deets on this via, I think, his GitHub site, which we'll look at as well. Very good in that there's a lot of information provided on the board itself, and from Atriva Tech. Okay, you can get a closer look at what is on this board, the front and the back, and let's go and get some blinky action going. Our first job is to plug this in and see if it is going to be fine with the Australian 5 volts. Well, that's a good sign. Oh, that's a little unexpected. Okay, so we've got a power LED up in the top left-hand corner, a blue one, and then a lot of RGB action, and I'm assuming from that it's addressable as well. Let's go and have a look at some of the specs on this guy, just comparing, well, firstly the RP2040 to the Atmel 328P, but then also let's have a look at what's on this specific board and how it came to be.
So I've just got a side-by-side comparison here of the RP2040 and the Atmega 328P. It doesn't tell the full story, but just to give you a bit of an idea of why you might use one or the other. Obviously, the familiarity and the resources with the Atmega 328P is a major plus factor, but have a look at that clock speed. So the RP2040 up to 133 megahertz as opposed to 20 megahertz. That is a big difference. Also, typically 2 megabyte flash compared to 32 kilobyte, huge difference. And even look at that SRAM, 264 kilobytes as opposed to 2 kilobytes. No EEPROM on the RP2040, but presumably external EEPROM would be pretty easy to add. I don't think we should pay much attention to the GPIOs because I'm guessing that because it's in the Uno format, it's going to be pretty much the same. Okay, welcome to Atul's project blog, and so here we've got the Pico and the Uno together. That's where the name comes about, and you can see the picture there pretty much matches, although that might be an earlier version. I don't see where the WS2812 is. That's obviously still under constant development. And in fact, okay, so it does direct you to another site. Future updates will be available. So maybe if we go to that site, yeah, we'll go to this site and have a look. Okay, well that's pretty flash. Okay, that looks a lot more like it. So you can see there the NeoPixel, and obviously a few changes. There's a reset button, and my version does have that. So we've got a reset button, and we've also got the boot select, important for programming. But it looks like it's sort of still in development, because it's got things like, it says here, get notified when it's probably going into production. This is pretty important. So the Raspberry Pi does have it's 3.3 volt, but if your peripherals are 5 volt, then you're going to need the level shifting. It looks like that's where it's taking place, which is how I've done it before as well, just via transistors. So I've certainly seen plenty of examples of that on this channel. USB-C, very good. Okay, so there's 8 megabytes of storage. So I think I said typically 2 in the comparison, but yeah, on the board there, that is 8 megabytes, which is extraordinarily generous. The Uno form factor, of course, which is important if you're putting a shield on it, which I will do. External DC jack for power. All the functions marked on the back, which we've seen from the picture. I still haven't found at this stage about how to access that WS2812 LED, but that's my next thing to do, next box to tick. Right, my first port of call is Earl Philhauer Arduino Pico, and it's got a lot of information here. It's obviously been around a while, but also it seems to be under constant development too. We've got something here which is from 2 weeks ago. That's pretty good. It seems directed at the Arduino Pico, but there is a lot of different boards for the RP2040 mentioned here. I'm hoping that one of those, that's a familiar guy. I've worked with that one before. I'm hoping that one of these will probably be useful. Yeah, so all that you need to do really is to copy this over into your boards manager, and if you've been mucking around with different chips, you'll know what to do there. And then all the information is needed, just go and choose that, and we're good to go. So let's have a look at our Arduino IDE. So I've done all of that. What haven't I done? Oh, I believe that the built-in for the for this board is 14. That's the built-in LED, is pin 14. I hope that's right. And then all you need to do is to choose the appropriate board from all of these different possibilities, and there are a lot of them. I'm just going to go with the Raspberry Pi Pico to start with. So if I go back to that, so it's just Raspberry Pi Pico. I'm just going to leave all of these as is. The only thing is that when I plug this one in, I actually hit the boot select and plugged in. So you notice that the RGB is not working anymore, and it should be, hopefully, able to be written to. So let me just try and upload that. This is a bit of a Hail Mary because I'm not even sure if it's supposed to work. It says scanning for RP2040 devices. Yeah, it doesn't look likely, does it? Nope. Let me just do that again just to make sure that I've done that right. So I'm going to hold the boot select button, plug it in, and put it back. So that should put it into the bootloader mode. Just make sure it's focused again. Yeah, it looks good. And let's try that again. So we're going to upload. Oh, one thing I didn't check was to see what the... Oh, wait a minute. I was going to say I didn't select the actual port, but it has found it. And, oh, look at that. So we actually have some blinking action as well. That is so cool. Let's set that to be quite fast. And it's possible that you might have to do that resetting every time. Let's see if it'll... Yeah, so that looks like that's the issue. You need to unplug it and plug it in every single time. That's a little tedious. Anyway, okay, let's try that again. So we will unplug, push the boot select button, plug it back in again, The blinking's gone away, which I guess is a good sign. Let me just adjust this. And we go again for compiling and uploading. And it's done. And look at that, the blinking is very quick. Cool. All right, the next thing I'd like to do is to find out how to get to that WS2812 RGB. That would be really nice. Okay, but that's progress. Nice. You can use the Arduino IDE and our normal code that we're all used to. Of course, you can use MicroPython or CircuitPython. I'm just going to stay with this for the moment. I'm very surprised that it worked straight off the bat, so that's lovely. And next thing to do is to find out how do I address that addressable LED. Right, so the NeoPixel, if I have read it right, is on 17. I had to dig around a little bit to find that, but I think it's on 17. I think the external LED is on 14. That was when we were blinking before, but the NeoPixel is on 17. I'm going to try the fast LED library. There's probably lots of different ways of doing this. Number of LEDs is just one, but that should cycle through the colors at least to see if this is working. So it should be in boot mode, I think. Let's try that now with the upload. I've tried to reduce the lighting a little bit. Oh, there's a few error messages there, or warnings. Hopefully that's okay. It's compiled correctly though, and it is uploading. Nothing so far. Oh, there we go. Oh yes, look at that. Okay, so 17 is correct. It looks as though that color cycling is fine under the WS2812, operating, as it turns out, for future reference, on pin 17. Let's put the shield on now and see if we can talk to it. This is coming along pretty well.
Here's the Multifunction Shield sitting on top of a genuine fake Arduino Uno. And I've just got some code running over and over just to test a couple of things on it. So it's by no means comprehensive, but the 4-digit 7-segment display is working fine, just counting from 1 to 4. At the same time, I've got the 4 LEDs going 1, 2, 3, 4 as well. And at the end of each change, there is a beep from the active buzzer. There's a lot of these different shields. I've chosen a particular library that suits this shield, but your mileage may vary. And of course, what I'd really love to do is to go in and write directly, but it was just easier to use the library that I found online. So I'll put a link to where that library is. And in fact, there's a whole series of tutorials on how to use these shields. And there's a lot of people complaining in the comments that their shield doesn't work because a lot of different manufacturers have their slight variations, let's say, on that shield. But now that that is working okay for the Arduino Uno, let's pop it over to the Pi version and see if it translates. This is going to be interesting. All right, some good news and some bad news. When trying to transfer this to the PicUNO, what happened was that first I had to rewrite a lot of the code and a lot of the library because some of the timing that's used for this, particularly for things like the clock and the shift register to drive the display, wasn't working on here. So, I made a bit of a go at it, a bit of a run at it. But in the end, when I put the shield on here, everything heated up and shorted. So I think that there's something maybe with the shields that you can use on here versus on the original Arduino. And I'll probably have to do a little bit more reading of the specs for Atul's version to find out if there are some differences in the way that the pins are configured. Another weird thing is when I put the shield back on the Arduino and reflash the Arduino with the code that was working before, I've got a couple of artifacts sitting up here on the display, which I'm pretty sure I didn't have before. Not sure what that's about. I don't think any damage was done in the transference backwards and forwards, but there you go. What we might do now is maybe have a chat to Atul. He's been very kind to give me some time. So what we'll do is we'll have a chat, a few questions with Atul, and then we'll wrap it up. Thank you for your time, Atul. Very, very pleased, firstly, that you can join me for a few questions about your wonderful product, but also thank you for sending it to me.
Happy to have sent it over. No issues with that whatsoever.
Excellent. And everyone's going to ask, of course, what's the weather like in Chennai at the moment?
It's extremely hot. It's the peak of summer. It's going to become even worse, I suppose. Around 35 degrees Celsius at the moment. It will maybe go up to even 40 soon.
Wow.
But sunny and good, I suppose.
Yeah, and high humidity or dry heat?
Extreme. Chennai is on the edge of the ocean, so humidity is at the peak, nearly 80 or 90%, I'm sure.
Wow. I wonder if that makes it more difficult, do you think, to developing electronics in that sort of heat and that sort of humidity?
Definitely, it does. But the bigger problem, I would say, is 3D printing, because the filaments are extremely temperature and humidity sensitive. So PLA and ABS, they don't sustain at all. PETG is even worse.
Yeah.
It's totally destroyed.
Yeah, I keep mine in a box with some dehumidifiers in there to try and even here we have relatively low humidity and low temperatures, but I still try and protect the filament because it can do a lot of weird things if it's got moisture in it.
Definitely.
Yeah.
That's a real issue here.
Cool. Let's have a chat about your product. So we can see it in front of us at the moment, and So this is the one that you sent me, which is plugged in and working. I've just accessed it to do some work with a little addressable RGB, the WS2812, which is working fine. And I was able to do a few other bits and pieces with it, which you'll see on the video. But tell me what motivated you to start the project in the first place.
Fundamentally, I started out with Arduino Unos maybe in my 5th grade, nearly 7 years ago. I started with electronics even prior to that, but since I have been using Arduinos, I decided when the Pico was launched, let's get into it. And that design, that form factor has been overused quite a bit, especially by students and people around me whom I have seen use Arduinos for quite a few years now. And the Pico is extremely powerful, so I thought, okay, maybe if we can integrate both of them into a single board, it would be useful. And roughly a year and a half or so ago, I believe I started out with the KiCad project. But I could not get going because of some prior commitments. It took me some time. And of course, Adafruit did beat me through it. They have added different features to their board. But the fundamental thing I did was I made sure it is more compatible with the Uno with level shifting and whatnot. So that was how the project started, maybe by effectively because of my interest in both the Pico and Uno, maybe joining them together, creating a mismatch, I suppose. Okay.
And are you calling it, I've been struggling to say whether it's PicUNO or PicUNO, or how are you saying it?
It's actually PicUNO, Pico and Uno together. It's like a joining of both of them. Many people have confused it with having a PIC-based processor. But the thing is that is just a standard name. The model is RP2040. That's the main difference.
Okay.
So in the future, hopefully there'll be multiple boards with different processors under the same name.
Yeah.
Just with different models. That would be the.
And just to point a few things out, so this is the latest version of the board that you've sent me. I can't find a version number on it, but what version is this one here?
That's effectively version 2.4, I believe. The other versions were not really released to the public, so that's effectively first version that has been put in production.
Okay.
But internally, it's 2.5, I suppose.
2.5. And you sent these ones and these ones, are they earlier versions?
The 3.3 is a totally different version. It doesn't have level shifting or anything like that. The other board with the rather large pads for the crystal oscillator, that one would be the previous version, 1.01, I suppose.
Okay.
The first version.
So it goes this one and then this one, and this is the latest one here.
Yep.
Okay. Very good. And you've sent me lots of little components here too. Thank you very much for that. I'll show that on the video, and a little keyring as well. Thank you so much. But those components are quite small. Are you hand soldering these? How are you putting these components on?
The capacitors and resistors are all hand soldered with a soldering iron. The main RP2040 is soldered on with a hot air gun. The rest of the through-hole parts are all with a soldering iron. That's pretty much it. It takes around 1.5 hours if I have to solder it by hand. But now I have built my own hot plate, so maybe that should simplify the process. Maybe within half an hour I can finish the board.
Yeah, excellent. And where do you see you're going next for the project? Like this is clearly still under development. What's next for this unit?
Definitely, there are a few more things that are required to be done. Software-wise, there's still a lot pending. There have been some more tweaks as well. There were some minor flaws in that board. They have been fixed too. The future plan would definitely be getting documentation done, targeting the educational market, since that's where Arduinos have been going. As luck would have it, I already have a small business that does educational tools and things like that that students can build. So integrating this will be a lot more easier, I feel.
Yeah.
Another thing that I'm considering is FPGAs. Luckily, the Pico form factor, the Pico chip RP2040 has been used to build FPGAs. So I am currently working on a Pico ICE port for the PicUNO, wherein there'll be a shield, which is just an FPGA. It can be connected to the PicUNO. It's still under development. Hopefully, maybe within a few months' time, it will be launched as well. A lot of work is there to be done, but FPGAs is definitely going to be the next major step after these small things get sorted.
So good both in terms of the flexibility, but also from an educational standpoint too. I mean, it opens up a whole new field really for the students to be effectively designing their own chip.
Definitely.
And one thing which I wasn't not real sure about, I've done a little bit of research, but can you take me through the connector at the end here?
Yeah, that is the SparkFun Quick ICE, the QWIIC, which is quick, pronounced as quick, I suppose. It's the I2C port, so that we can have a chain of sensors connected together, which can be interfaced with their I2C port. That is, depending on which port it is using, we can connect via the software serial or whatever we wish to do. And the advantage with Quick is it's a single port interface. So we don't need to have multiple wires, multiple interfaces that are being connected to all headers, wasting a lot of space. It is just a chain of sensors. So when I was discussing this project on the EEV blog forum a few months prior, some of the engineers there were suggesting that I add a Quick port or even a STEMMA QT port. That way, people who are already in the education field, who are already using those sensors made by SparkFun and Adafruit, can quickly use it with this board without having to invest in separate hardware or separate wires, complicating their project. So it will just be a simple thing. They have to just plug it in and it's good to go. They just have to write the code for it. So I decided, since it's going to be marketed towards students around the world, it is maybe a good idea to even integrate that system so that it will make the life easier for them.
Yeah, no, what a great idea! And I certainly know that in the school that I work in, the science department has a lot of I2C type sensors and also peripherals that would connect in. So that's a great idea. Can you maybe have talk a little bit about this chip here? This is your EEPROM, I guess, is it?
Yeah, that's like the EEPROM. That's the flash storage, actually. It's made by Winbond. I believe it's 8 MB at the moment. Like maybe in the future, maybe in the final production version, there'll be more storage. Another thing is I have increased the storage when compared to the main Pico itself, so that if somebody is considering VGA, maybe building their own port of a game or something to it, maybe the Commodore 64 or some sort of complex old 8-bit system, maybe porting it over to this board, a lot of storage will be required to house the virtualization software and such. So I decided maybe adding a bit more storage would be useful. That is effectively the flash chip. It's a Winbond, some standardized chip by Winbond.
Yeah, great. Yeah, I've used those with
the ESP ones.
Yeah, the ESP8266, and just increased the flash available, which is really great. And the jumper here.
I remember that video.
Yes.
Yeah, that jumper is actually to enable the NeoPixel on demand. That I have added it so that if somebody would like to use that GPIO, I think it's connected to GPIO 17. if somebody would like to use that GPIO for some other purpose and they're sending some signals, if I were to have directly connected the NeoPixel, it'll show a lot of erroneous colors. It'll glow randomly because of just random bits of data that be going across on accident. So to prevent this waste of energy, I would say, because when it turns on, it draws a lot of current. So if the user doesn't want the NeoPixel, they have to just remove the header and it's good to go. The NeoPixel won't work. They can use the GPIO for whatever they want.
Okay.
That's, which I have added.
And the transistors at the back here, that's your 4-level shifted, so 5-volt tolerant pins?
GPIO 2 to 5 are level shifted to 5 volts, but that only works on external power input for safety reasons. So if somebody is accidentally connecting in 3.3 volt Bluetooth HC05 or something, it'll get definitely fry if 5 volts were to go across it. So I decided, let us add a safety barrier. It will only work with 5 volts. So with external power input when it has to give out 5 volts. Yeah. It is a safety feature.
Excellent. Well, I'm very impressed. It's a very powerful and obviously extensible module. So I think it's got a great future, particularly in education. I think it's wonderful. I mean, the Arduino Uno has been around now and in education institutes for probably a good 15 years or so. So this is a great evolution. One thing which I did have a question about, this multifunction shield, which is pretty common. I mean, there's lots of different varieties, and you just put it on top of a Uno, and then you've got access to the 4-digit 7-segment display. There's a buzzer, there's a pot, some pins, some LEDs. So I've just got it running some test code at the moment. I had problems putting it onto here for a couple of different reasons, but one of the ones that scared me the most was I'm just wondering how compatible are these pins, because when I put it on there, I think it pretty much shorted out your module. It hasn't caused any permanent damage, but have you got any sort of thoughts on standard shields like this to be fitted onto your module?
Yeah, that is something that I'm still testing out, standardization of shields. At the moment, I only tested out the L293D and some motor drivers and things like that. The standardized multi-output shield I'm yet to test out actually. The only difference is certain ports have been changed on the power headers, like the IO REF has been replaced with a standard 3.3 volt direct output, which might be grounded on the Uno, because on the clones it is not, but on the original one it was, I suppose. So that is something that I am still working on fixing. So that is why I was actually handing out these devices to testers, because there are still some hidden flaws which I have not found personally, but they are existing and I'm sure of it. So things like this, like now, since I've now been told of this minor issue, I will definitely test it out, maybe even fix it up, because this is something that is extremely standard. It should not cause a problem really, but considering it is maybe a small change that I have made, maybe it could be creating a minor issue. So
yeah, I mean,
I can get it fixed.
Yeah, that's all. I mean, it's obviously all part of the development process. And I mean, the problem is with this. I mean, if you go online and have a look at a shield like this, people have got massive problems because all different manufacturers with all different components and all different specifications. And this shield causes some problems just with Arduino Uno. So I'm not sure how much you want to chase to put it on here. But I just noticed that. So I thought, well, that's an interesting thing. I did a lot of. But
we should make sure that our board works in whatever scenario it is in, because in the hands of a student, we don't know. They will try something out randomly, put 3.3 to ground, the board cannot explode randomly. There should be some safety measures, especially with things like this. I'm sure that somewhere in the globe, people must be trying. It works with 1 or 2 pieces. There's a 50% chance that it'll at least work in the hands of
the person. I mean, I actually like that. Atul. I like the idea of something blowing up and then trying to figure out why that happened. So thank you again for your time. Were there any questions that you had for me before I release you to do some normal stuff in your life?
The thing was, I wanted to know if you found any flaws. Obviously, a flaw has been found with the standard shield, I suppose. That's one thing. Another thing is, I do understand that you do like the Padauk series of chips, which are 3 cents, 4 cents each. But I have, if you were to look at the programmer, I know that it's somewhat on the pricier end. There are some standardized things, I suppose, but still, it does cost quite a bit, even though the chip is a bit cheaper. So I was thinking on a general programming basis, if I were to have a product maybe where I have to keep on changing the code multiple times, would you go to a cutout chip or would you prefer an 8010?
That's a very good question. I mean, the Purdue chip for me was initially I liked the idea of a reverse engineering. I love the fact that the EEV blog people did some work on a programmer, which I was eventually able to successfully make. And I know that you can buy the commercial one, and yes, it is expensive, but in the end, I think all the different variations of the open source programmer are fine. And I've made up about 5 of the programmers, and they've been fine. I went for the PFS 154 initially because I was attracted to the 3 PWM channels. And that because I'm working on this candle project, which I've been working on forever, and I like the idea of 3 separate channels as opposed to 2. So that's what initially attracted me to it. Plus the fact that the PFS 154 has 2K of flash, not 1K like the A-Tiny 13. But one of the flaws which I found out when I tried to apply it to another project is there's no ADC on it, unlike the A-Tiny 13. So I'm now starting to think about the PFS 173, very similar chip, still got the same 3 PWM channels, does have an ADC which is good, and it has 3K of flash RAM. So I may go down that pathway. I mean, I just liked it because it was quirky and difficult. I'm not sure that it's that useful, but I imagine if you have a single product in mind and it does what you want to do, it's been a very reliable chip. It's cheap. So I certainly would recommend it from that point. I think we'll find the Purdue in a lot of like small consumer products where, maybe even just something simple like a kettle, just monitoring, the temperature and when to cut it. I don't know, but I just think it does have a capacity for that. I guess what I like to do is to try and squeeze as much out of it as I can, given that it's quite a quirky chip. I'm actually more attracted these days to the, it's called the CH32V003, which is, I think it's got a lot more speed, capacity, a lot more peripherals. I'll probably head down that pathway. So I've just ordered some chips and now I've just got to find out how to program them.
The WCH series of chips, I remember I was wanting to try them out when they were on sale locally here. Didn't have the time, but they do seem quite useful. I think WCH is also the people who make those USB to TTL logic chips for all of these.
Yeah, that's how It was the old CH340, which is even on the old Arduino boards, the UART chips. That's how they started. But the modern incarnations are just brilliant. So that's one company I think to keep an eye out for. They seem to be under constant development. Their chips are pretty good. They've got good capacity. I think the difficulty is that sometimes when I've gone looking for information for them, I run into a Chinese data sheet, and that slows me up a little bit.
Yes,
Yeah.
It takes a while even for Google Translate to get its job done around it.
Yeah, it does remind me of the Purdue chips earlier on. All the data sheets were in Chinese, and that made it very difficult. But now, of course, they've all been translated and updated, and I imagine as the product spreads wider, that will happen to these chips as well.
Definitely, that's for sure. When the market grows, innovation will also change.
Yeah.
Another question I was asking is, I do understand your background is in mathematics. I was just wondering what brought you into electronics as a hobby, especially because I have spoken to some people who are maths teachers of my own who don't seem to have any inclination towards building things like this. So it just makes me feel interested, actually.
Yeah.
It gives me a different way.
Yeah, I really don't know. I mean, I have a lot of different interests, and I just started with the electronics stuff, and I think I arrived with my electronics hobby at a golden time when AliExpress was cheap. There was, I think, the Chinese government was funding them for things like their freight. Our government hadn't picked up that because we have a goods and services tax, which they weren't applying to it. The electronics were extraordinarily cheap. It was before the pandemic, before any of the supply chain issues, and I just bought a heap of stuff. And then I got to the point, maybe a couple of years into that, where I thought I'm not using it. So I thought what I might do is just to start to make a channel and just do some simple circuits, and it all really started from there. I don't do the channel with any sense of purpose, and I imagine people will be quite frustrated sometimes. Like, is he the ESP32 guy? Is he the A2013 guy? There's all sorts of weird and wonderful stuff on there. But really, what I'm doing is I'm just following what I'm interested in, and then I just record it. For next time that I'm trying to figure out how a particular transistor works, hopefully I've already got it recorded, and that speeds up the next process. So that's basically where it's come from. I'm not really sure, but it is a weird mix. I'll give you that.
I have been following your channel for, I don't know, I believe more than a year at this point. I think it started out when I was watching mailbags just for fun, just to relax. I used to watch mailbags, Mr. Stuff, pile of stuff, and then I came across your channel. So I was like, okay, let's just go deep. I started liking your videos, so then I started interacting with them. I still watch. So I thought, okay, if we have built something, let us just send it to OneCircuit. Maybe we can find out if there are any flaws. And I am extremely happy that you even accepted, actually, because I don't know for a fact that it's not an easy thing. Usually people get frustrated when we tell them to test things out. Usually sometimes they don't want us to pay and all of those things. You just told, just send it over, I'll have a look at it. So I was extremely glad, actually, because the feedback is what helps my product grow, even my own hands-on skill set. So I would like to thank you a lot for that, for choosing to,
Oh, it's my pleasure, and I like the product. I think at this stage it probably fits into the what I call exotic, tech, where you've got this lovely combination between an old form factor and the new chip and other peripherals on the board, and the possibilities of expansion. So I just love that sort of stuff, and I really wish you the best of luck in your development, and please stay in touch with with what's coming. I'm always happy to have a look at what you've got available. And there's a package coming your way, so maybe when we finish up this interview, we'll have a bit of a think about what you might want in that in return, because I love the little keychain here, and there's a few local things from Tasmania that you might be interested in, so I can put that in as well. But
definitely,
yeah. Let's finish up the
sandalwood keychain. That's a sandalwood keychain. It have a very exotic smell to it. It's an indigenous product to our nation, actually. So
I love sandalwood. In fact, I make fragrance for myself, which includes sandalwood.
Exactly.
Yeah, it's very nice. And sandalwood soap from I think it's Bangalore. It's I buy that. I think it's called Mysore.
It's
very good soap.
Karnataka. That's where it's grown. Yes.
Yeah,
it's a geographical indicator, actually, to Karnataka.
Yeah.
The Mysore sandalwood. So
yeah, it's fantastic.
I could have definitely sent something else, but those may not last by the time they reach you, maybe 14 or 15 days later. So I thought, what was the next best thing? A keychain. Maybe you can use it wherever you want. So
fantastic.
Sandalwood. So I thought, okay, let us just send it. So anyways, I am sending some creations of mine. So let us also add in a quick small gift.
Yeah, very much appreciated. And thank you for your time today. We might finish up the official interview here, and I was just wondering if you'd love to do the sign-off for me, if you'd love to say that's the circuit working. We'll see you next week.
Sure. So that's the circuit working, and we'll see you next week.
Brilliant. Thanks, Atul. See you again.
Thank you.